Namaste. Hello, hi everyone. Welcome to Student Brand. This is your Shiva sir. So in the previous class, okay, so come to the point. So in the previous class, we discussed until terms related to spherical mirror. Terms related to spherical mirror. Now we are going to discuss one more. Ray rules of concave mirror and convex mirror. So continuation topic. So this is a continuation problems and few problems also will do. Few questions also will discuss. Few problems and questions. So we'll discuss question and answers. And what is the radius of curvature? What is the radius of curvature? So distance between. So once again we will recall the previous topic. Reflection is nothing but the bouncing back of the light from the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light. The bouncing back of the light from the reflecting surface is called a reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. And angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. So these are the reflection phenomena and angle between incident ray and reflected ray. And Angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. So these are the angles. And loss of reflection, incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So next, angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. Regular reflection, incident light rays are parallel, reflector light rays are also parallel to each other. Incident light rays are parallel, reflector light rays also parallel to each other. That is called regular reflection. Coming to irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, reflector light rays are not parallel to each other. Irregular reflection. So on highly polished smooth surface plane mirror, on plane mirror regular reflection takes place, on wall irregular reflection takes place. Okay, so next one, object and image. Object and image. Object is real, image is virtual. Object is virtual, image is real. So that is about object and image. And the next one more. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Object is real, image is virtual. Object is virtual, image is real. And the object distance is equal to image distance. Height of the image is equal to height of the object. And it also shows lateral inversion. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. That is the lateral inversion. And coming to the one more terms related to spherical mirror. Center of curvature, pole, radius of curvature, focal length, focus, aperture. Okay, so these are all points. Next one, we are going to discuss a few more points. Those are we will discuss now. Those are so ray rules. Will discuss ray rules of concave mirror and convex mirror. Concave mirror, concave mirror and convex mirror. Concave mirror and a convex mirror. Convex mirror. So concave mirror, if you are taking, so I'm taking the concave mirror. Okay, pole, focus, and center of curvature. Pole, focus, center of curvature. Light ray is coming from infinity. Light ray is coming from infinity after reflection passes through the focus. Second one. So pole, focus, center of curvature, light ray passing through center of curvature. After reflection moves towards infinity. Third one. So pole, focus, center of curvature, light ray is passing along the center of curvature. It reflects back into the same path. Next one. So I'm going to the one more. So pole, focus, center of curvature, light ray incident near the pole, it reflects back. Okay, so these are the so first one I'm taking convex mirror. So pole, focus, center of curvature, light ray is parallel to the principal axis after reflection passes through focus. Second one, light ray is passing through focus. After reflection moves towards infinity. Third one, so pole, focus, central curvature, light ray passing through central curvature. So it passes through central curvature. Fourth one, light ray is incident at the pole, it reflect back. So this is the pole, focus, central curvature, light ray incident at the pole, it reflect back. So this is about ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Coming to the image formation. So image formations will discuss. Image formation. Okay, object is at infinity, image will form at focus. Object is at infinity, image will form at focus. Okay, so now. So concave mirror. So pole, focus, central curvature, object is at infinity, image is forming at focus. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I'm taking one light ray like this and another light ray after reflection passes through focus like this. So here I'm considering here and here. Object is at infinity, image is forming at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the second one. So pole, focus, central curvature, object is placed beyond central curvature. How many light rays? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I'm taking one light ray like this. After reflection passes through focus. Another light ray passes through central curvature. Okay. So the image will form between C and F. Okay. So image will form between C and F. Object is beyond C. Image will form between C and F. Object is placed beyond C. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. Nature of the image is real and inverted. Size of the image is diminished. Okay, coming to the second one. I'm taking second one. So third one. So here pole, focus, central curvature. Object is placed at C. Image will form at C itself. Object is placed at C. Image also will form at C. Nature of the image is real, inverted and same size. One light I am taking like this. So it passes through focus. Another light is incident at the pole. It reflects back. Okay, object is at C, image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Same size, okay? Size of the image is same size. Coming to the fourth one. Fourth image formation. Object is placed. So this is the pole, focus, center of curvature, pole, focus and center of curvature. Object is placed between C and F. One light I am taking like this, it passes through focus. Okay. Another light I am taking at the pole. So it reflects. The light rays will meet. Beyond center of curvature, image will form here. Object is placed between C and F. Object is placed between C and F. Image will form beyond center of curvature. Object is placed between C and F. Image will form beyond center of curvature. Nature of the image is real, inverted and enlarged. Real, inverted and enlarged. Object is placed between C and F. Image will form beyond center of curvature. Beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Size of the image is enlarged. Size of the image is enlarged. Okay. So coming to the fifth one. Fifth one I am taking. Object is placed. Object is placed. So this is the pole. Focus. Center of curvature. Object is placed at F. So one light I am taking like this, passes through focus. Another light ray is incident at the pole, reflect back. Okay. So these light rays will meet. Object is at F. Image will form at infinity. Object is at F. Image will form at infinity. Nature of the image is real and inverted. And size of the image is high. Sorry. Object is placed at F, image will form at infinity. So this already, if object is placed between C and F, image will form beyond center of curvature. Object is placed at F, image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Coming to the sixth one. Sixth one. So I am taking here. So pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. Object is placed between F and P. Image will form. Image will form. So behind the mirror. Object is placed between F and P. Image will form behind the mirror. Behind the mirror. Nature of the image is virtual erect. Nature of the image is virtual erect and enlarged. Virtual erect and enlarged. Virtual erect and enlarged. Virtual erect and enlarged. Okay. So next one, we'll discuss about convex mirror image formation. So this is about concave mirror. We'll go to the convex mirror image formation. Okay, so coming to the convex mirror, I'm taking the convex mirror. So pole, focus, center of curvature, object is placed at infinity, image will form at focus. So I'm taking two light rays like this. So after reflection, those are moving away. So image will form at focus. So object is at infinity, image will form at focus. Nature of the image is virtual erect and diminished, highly diminished. Coming to the second one, object is placed. So pole, focus, center of curvature, object is placed here. So how many light rays are required to form the image of the object? Minimum 2 light rays. So I'm taking one light ray like this. So it reflect back. Another light ray incidentting at the pole. Another light ray incidentting at the pole. So at the pole, it reflect back. If you are extending this one, it passes through the focus. The image will form. Object is placed between P and infinity. Image will form between P and F. P and F, P and F, P and F. Nature of the image is virtual erect and diminished. Virtual erect and diminished. Okay. So next one, sign conventions. We'll discuss about sign conventions. Okay. So let's start sign conventions. Sign conventions. New Cartesian. Sign convention. New Cartesian. Sign convention. All distance are measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian. Sign convention. New Cartesian. Sign convention. All distance are measured from the pole. Distance are positive along the incident trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to incident rays, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention. So here I am considering, here everybody listen here, I am taking the mirror, spherical mirror, I am considering the mirror here. All measurements will be taken from the pole. All measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all distances are positive. Below the principal axis, all distances are negative. As you can see, the coordinate axis, positive x-axis, positive x-axis, negative x-axis, positive y-axis, negative y-axis. So in the direction of incident rays, all measurements will be taken from the pole. In the direction of incident rays, all are positive. Those are, so positive object distance, image distance, focal length and radius of curvature. Opposite to object distance, image distance, focal length and radius of curvature, negative. Above the principal axis, so height of the image and height of the object, positive. Below the principal axis, height of the image and height of the object, negative. Okay. So this is about new Cartesian sign convention. Simply we can say sign conventions. Once again, all distances are measured from the pole. Along the incident rays, positive, opposite incident rays, negative. Above the principal axis, positive. Below the principal axis, negative. So that is, I converted in the form of song. So this is the song. New Cartesian, sign convention, new Cartesian, sign convention, all distance measured from the pole, distance positive along the instant rays, distance are negative, opposite to instant rays, distance are positive, above the principal axis, distance are negative, below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention. Yes, so this is about new Cartesian sign convention, new Cartesian sign conventions. So I hope it is clear. So as we know, all distance will be measured from the pole. In the direction of incident positive, opposite incident is negative. Above it is positive, below it is negative. Okay. So now we'll discuss few more. That is mirror formula. Mirror formula. Okay, done. Now, mirror formula 1 by f equal to 1 by u plus 1 by v. Magnification equal to height of the image by height of the object. Mirror formula is 1 by f equal to 1 by v plus 1 by u. Magnification is height of the image by height of the object. So this is about sign conventions, and now we'll discuss few more problems. Problems we'll discuss. So as we discussed here, so point number 1, name a mirror that can give, so anyone can tell the answer. Name a mirror that can give an erect and enlarged image of an object. Name a mirror which can give erect and enlarged image of an object. Name a mirror which can give erect and enlarged. So what is the answer? Concave mirror. Why do we prefer convex mirror as a rear view mirror? Why do we prefer convex mirror as a rear view mirror? Because, so can anyone answer it? Why do you prefer convex mirror as a rear view mirror? Why do we prefer convex mirror as a rear view mirror? Anyone can tell the answer for it? Convex mirror as a rear view mirror. Convex mirror as a rear view mirror. Okay, wider field view, and always it forms virtual erect and diminished image. Always it forms virtual erect and diminished image. So it gives the wider field view. Field view is nothing but, so the region between the two extreme reflected light rays. Okay. This question is very bigger, but still. So in headlights of a car, which mirror we will use in headlights of a car? Headlights of a car. Which mirror will be using in the headlights of a car? Headlights of a car. Anyone can tell the answer? Headlights of a car. You do which mirror? Concave mirror. Side view mirror, rear view mirror. Side view mirror, rear view mirror. Side view mirror or rear view mirror. So side view mirror, rear view mirror is convex. Side view or rear view mirror is convex. Solar furnace. So which mirror used in solar furnace? Solar furnace. Solar furnace. Which mirror used in solar furnace? Which mirror used in solar furnace? Solar furnace. Solar. Which mirror? Concave mirror. Very good. Next. Next, one more question. What is the focal length of concave mirror? Positive or negative? Focal length of concave mirror. Focal length of concave mirror is positive or negative? Focal length of concave mirror. Focal length of concave mirror. Positive or negative? Focal length of concave mirror. Positive or negative? Negative. Very good. Focal length of convex mirror. Focal length of convex mirror. Focal length of convex mirror. Negative or positive? Positive. Okay. Okay, a person is standing in front of the plane mirror. A person is standing in front of the plane mirror. His head is small. Okay, so body is bigger, legs are normal size. What type of mirrors? Head is small, convex. Body is normal, plane mirror. Legs are small, body is bigger means concave. Head is small, convex. Body is bigger means concave, legs are normal size means plane mirror. So that is the order. So check once. If a head is small, small means so convex mirror. So body is bigger, concave. Legs are normal, plane mirror. Okay. So these type of questions they will ask. One more question. One more question. How can you identify the three types of mirrors without touching it? How can you identify three types of mirrors? How can you identify three types of mirrors without touching? Without touching. First one, concave mirror, virtual erect image will form. Convex mirror in the tail. So with the help of images. So with the help of images, what type of images will form? Based on that one we can identify. In concave mirror, virtual erect and enlarged. Convex mirror, virtual erect and diminished. Plane mirror, so virtual erect and same size. Okay. So that's enough related to that. Next one, few problems, sign conventions related to sign conventions. Few problems are there. So I'll give one question, try to solve it. I'll give one question, try to solve it. So can anyone tell this answer? Question number 2 minutes time. Try to do this. Okay. Okay, here you can observe where should an object be placed in front of concave mirror. Focal length is given. Focal length is given. So as to obtain a real image, 2 times of magnified. 2 times of magnified. In that case, so yeah, you have to identify first. So after identifying, you have to take, so focal length is minus 20 centimeter. Second one, magnification equal to minus v by u equal to, okay, so real image is formed. Real image is positive or negative? 2 times of magnified. How can we take? Anyone? How can we take magnification? Positive or negative? No answer. Okay, done. Real image means minus you have to take. Virtual image means positive. So minus v equal to u minus 2. So plus or minus we can take. V equal to 2u. Now 1 by f equal to 1 by v plus 1 by u. Then minus 1 by 20 equal to 1 by 2u plus 1 by u. Then 1 by minus 20 equal to, so 2u is the LCM, 1 plus 2, 1 plus 2, then minus 1 by 20 equal to 3 by 2u. So 2 10 ja, u equal to minus 30. Minus 30 centimeter. This is the answer. Okay. So this is about, see, first you have to take focal length minus 20, magnification equal to minus by u, that is minus 2. So minus v by u equal to minus 2, v equal to u, 1 by f equal to 1 by v plus 1 by u. So substituting, then you can substitute in this case. Then you will get 1 by minus 20 equal to 1 plus 2 by 2u. Then minus 1 by 20. So 2 to get cancel. Then you will get u equal to minus 30 centimeter. Okay, so thank you. Next one, we'll go to the next concept, that is about refraction. Refraction of light. So refraction is nothing but the bending of the light. The bending of the light at the interference of the two media. So refraction is nothing but rarer medium, denser medium, Light ray is passing from rarer to denser. So this is the normal line. So angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. When the light ray is moving from rarer to denser, it bends towards a normal line. When the light ray is passing from one medium to another medium, so the path of the light changes. The path of the light changes. Okay. So if it is moving from rarer to denser, it bends towards the normal line. It bends towards the normal line. Angle between incident and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle of refraction. Okay. So now we can see laws of refraction. Laws of refraction. Laws of refraction. First one is incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. Second one is angle of incident is equal to angle of refract. Sorry, that is loss of reflection. Sine of angle of incident to sine of angle of incidence to sine of angle of refraction equal to constant. Okay. So incident ray, refracted ray, normal line lies in the same plane. So here sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. Okay. So sin I by sin r, that is equal to n. N is the refractive index. N is the refractive index C by V. N is the refractive index C by V. Speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. N equal to C by V. Speed of light in vacuum by speed of light in medium. Okay, that is absolute refractive index. Coming to relative refractive index. Relative refractive index N21 equal to N2 by N1 equal to V1 by V2. V1 by V2. So refractive index is nothing but speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. So absolute refractive index is nothing but refractive index with respect to speed of light in vacuum or air or vacuum. So one medium compulsory, one medium must be speed of light in vacuum. Another medium is different. You can take water, glass, a different medium you are considering. That is absolute refractive index. Whereas relative refractive index, so you can take, so you are considering water with respect to glass with respect to different medium other than so air or vacuum, that is relative refractive index. Absolute refractive index means so one medium must be speed of light in vacuum or air. Okay, so this is enough. Next one we are going to the one more. This is about loss of refraction. Incident ray, refracted ray, normal lies in the same plane. Sine of angle of incident to sine of angle of refraction equal to constant. So n equal to C by V. N21 equal to N2 by N1. That is nothing but V1 by V2. So this is about refractive index, loss of refraction. Loss of refraction. So we are going to the next topic, that is critical angle and total internal reflection. We will discuss about critical angle and total internal reflection. Critical angle and total internal reflection. Critical angle is nothing but that certain angle of incidence the refracted ray gauges along the surface or passes along the surface is called critical angle. So the angle at which the refracted ray passes along the surface. So I'm taking here, normally if the light ray is passing from rarer to denser, so it bends towards the normal line. Okay, it will bend towards the normal line. But so here I'm taking light ray is passing from denser to rarer. Light ray is passing from denser to rarer, it moves away from the normal line. If it is passing from denser to rarer, the angle at which in the rarer medium, the refracted ray passes along the surface, it passes along the surface or gauges along the surface. Angle of incident is equal to critical angle. So it makes 90 degrees with the normal line. Okay. So the refracted ray makes 90 degrees with the normal line. So refracted ray makes 90 degrees with the normal line. Okay. Next one. So the light ray is passing from denser to rarer. The light ray is passing from denser to rarer. So refracted ray makes more than 90 degrees. Refracted ray makes more than 90 degrees. Then it reflects back into the same medium. Okay. So refracted ray makes more than 90 degrees, then reflect back into the same medium. Understood? Once again, here you can observe if the light ray passing from denser to rarer, it moves away from the normal line. So here, if the light ray passing from denser to rarer, at certain angle of incidence, the refracted ray makes 90 degrees with the normal line. 90 degrees with the normal line, that is called critical angle. If the light ray passing from denser to rarer, it makes more than 90 degrees. Then it reflects back into the same medium. That is called total internal reflection. Refracted ray makes more than 90 degree, more than critical angle. Then the light ray will reflect back into the same medium. So this phenomenon is called total internal reflection. Okay. So the angle at which refracted ray passes or gauges along the surface, or it makes 90 degrees with the normal line. That is called critical angle. So refracted ray makes more than 90 degrees, then reflect back into the same medium, right? Yes. Next, lenses. We are going to the lens. So there are two types of lenses are there, convex lens and concave lens. Convex lens. Okay. Now, so we'll discuss convex lens and concave lens. Convex lens and concave lens. Convex lens and concave lens. If light ray is coming from infinity after refraction, light ray is coming from infinity after refraction passes through focus. Light ray is coming from infinity after refraction passes through focus. So first one coming to the second one. Light ray is passing through focus. Third one. Coming to concave lens. Grade CBSE. CBSE grade 10 physics. Okay. Okay, so here I am considering object is at infinity, image will form at focus. So nature of the image real and inverted and highly diminished. Object is placed beyond 2f1, image will form between f2 and 2f2. Nature of the image is real and inverted and diminished. So here object is placed at f1, 2f1, image will form at 2f2. Nature of the image is real and inverted and same size. So object is placed between 2f1 and f1, image will form beyond 2f2. Nature of the image is real and inverted and enlarged. Object is placed at f1, image will form at infinity. Nature of the image is real inverted and highly enlarged. Object is placed between f1 and o, image will form same side of the object. Nature of the image is virtual erect and enlarged. So thank you so much everyone for joining and attending a listening class. So we'll see you in the next class with the more content and with different topic. Thank you so much. See you soon. Thank you.